Now I'll discuss with you some important vector identities. We have some important vector identities. I'll list down those vector identities and then I'll discuss with you which one is more important, right? So I'll write down the vector identities one by one. So I can write it from, there are 9 or 10 vector identities which are very important. They are, so you have these identities. Of these identities, see, these two are quite obvious, nothing to remember over here. These two are very, very important. They find a lot of use. All right, these two are very, very important, and these are very important for the student of physics side, because in physics you have this application of this in pointing vectors. Here application of this in EM waves, and these two are also very important. There's a huge application in the basic sciences. So for the student of mathematics, you must remember these two at least. All right, those who are in physics, they must remember, apart from these three, these two, this one and this one also. Here the problem which I'll solve, most of the problem I'll solve without using these identities. I usually advise you to solve it using the definition only, like grad of phi is sigma I d by dx of phi. I'll advise you to use this only. Del dot f, the divergence, is being defined as I dot del by del x f, right, and del cross f equals to I cross del by del x f. I usually advise you to solve using these definition itself, because many times you won't be able to remember this, right? Many times you won't be able to remember these are very big, you won't be able to remember this. So you must practice to solve all the problems of this chapter using these definitions only, and I'll tell you how. It will take time to learn, but once you learn it, it will be very helpful. But before going to solve the problems using this method, using this definition, you must learn something like the important thing which you must keep into the mind. You can learn these identities also, but if you don't learn it, even then it's okay, right? So you please learn something which will be very important while solving the problem. Like wherever you are given, say, r vector, it means xi, yj, zk. Wherever you are given r, it means the magnitude of this r vector, that is x square, y square, z square. Sometimes you are given d dou r by dou x, so it will be under root x upon under root x square, y square, z square. So this will be x upon r. Similarly, dou r by dou y is y upon r, and dou r by dou z will be z upon r. All right. Now one more thing, you must know that you must remember that d by dou x 1 upon r n. This thing you must remember, right? This is something which you must remember. This will be n upon r n plus 1 dou r by dou x, which will be nothing but nx upon r n plus 2. Remember this. Similarly, you must remember a is equal to a dot I. What is a dot I? A dot I is the x component of a, I, plus a dot j, j, plus a dot k, k. Remember all these things. Remember all these things, that will help you. This must be at your tips. All right, you don't have to think while applying all these things. So you remember this, all these things. These are very, very important. Right, these are very, very important while solving the problem. So you must remember all these things. I'll take up one problem and solve using the definitions only, right? So I'll take up the problem. So before I do this, I rub this. All right, so I'll take up a problem on the application on this divergence, right? So this is a very famous problem. Prove that divergence of r upon r cube is 0. Prove that divergence of r upon r cube is 0. So I'll prove it, say over here. What is divergence? Divergence we have to prove this. See, divergence by definition is I dot dou by dou x r upon r cube. Now I can write this as I dot, this can be written as 1 upon r cube. I am applying chain rule, r plus 1. One more thing I'll tell you. See, you must remember this d dou r by dou x as I, apart from the what I told you earlier, j, and dou r by dou z is k. Remember this also. It will help you. So you see 1 upon r cube dou r by dou x. So this gives you I dot minus 3 upon r4 minus 3 upon r4 dou r by dou x r vector on 1 upon r cube I vector. Alright, this is a capped bigger bracket. So this will give you dr dou r by dou x is x upon r. So this will give minus 3x upon r5 I dot r. Alright, I dot r plus 1 by r cube I dot I. So this will be equal to I dot r is what? X only. So it is 3x square upon r5 1 upon r cube. So this will give you 3 upon r5, sorry, 3 upon r5 sigma x square and 1 upon r cube sigma 1, which is nothing but sigma x square is x square plus y square plus z square. So this will be 3r square upon r4, sorry, r5, and sigma 1 is 3 upon, which is 0. This is very important, right? This becomes 0. So you have to remember these things, right? So this becomes 0. Alright, so this is a problem on divergence. I'll do the other problems, right? Let's go to the next question.